Good day and welcome to SUSECon 2023. This is session tutorial 1097, an introduction to Rancher Desktop. My name is Dwayne Sims. I'm a sales engineer with SUSE in the Southeast US, and I'm joined today by Colin Griffin, who is the chief engineer at Crumware. He'll be doing the demo of Rancher Desktop toward the end of this. Just a quick agenda of what we're going to be covering. I'm going to give you a super brief introduction to Rancher products and really the whole SUSE product line. It's going to be very brief. I know there's a lot of other sessions going on at SUSECon that talk about Rancher products. And so I just kind of want to set the stage a little bit as we talk about Rancher Desktop. But we have lots of sessions that will cover these in much more depth. So I'll just give you a little taste of what's going on with Rancher. Also, we're going to dig into Kubernetes on the desktop and why you might want to run Kubernetes on the desktop and see some of the solutions that are out there. Then we'll take a deeper dive into Rancher Desktop itself and why it was built in the first place and kind of where it's at today. And then we'll turn it over to Colin and let him do the demo for you folks. So as we take a look at this chart here, you see three layers of this, and the top layer is really the cloud native Kubernetes based products that we have, and these are the Rancher products. And the headliner there is the Rancher Management Server. Rancher is that management framework and dashboard that Kubernetes always needed. And again, as I tell folks a lot of times, if you're managing one Kubernetes cluster or maybe even 5 Kubernetes clusters, you probably don't need Rancher. You can get by with using other tools, command line based tools to manage things at that scale. But when you start scaling up, and that's what we see with customers that start to deploy Kubernetes, they start off with one cluster, and the next thing you know, they've got 20 or they've got 50. That's what tends to happen when you start deploying this. And that's really when Rancher comes into play to let you have common policies and common procedures for dealing with all of those disparate Kubernetes clusters that you might have out there, especially when you get into things like a mixed environment where you're running some things on-prem, things in multiple clouds, running stuff at the edge. That's when it really begins to be a great tool for those kind of environments. And that's what people tend to grow into as they look at this. So that's what the Rancher Management Server is all about. Then we have things like Longhorn, which is a block storage solution for Kubernetes, especially in a hyper-converged sort of environment that allows your worker nodes to actually be turned into storage nodes. And to do that in a robust and highly available fashion so that your data is not in danger. But it gives you that ability to have block storage available to your containers and your pods that are running on Kubernetes in such a way that I don't have to worry about an external storage system to provide that. And that's what Longhorn is all about. We also have the Kubernetes distributions. We have RKE and its cousin RKE2. These are more mainstream Kubernetes distributions, really aimed at data center sort of deployments. And then we have K3S. K3S is a really lightweight Kubernetes distribution that's really aimed at things where you don't have a lot of computing power behind it. In fact, I have K3S running here in my home office on a Raspberry Pi. I think that Raspberry Pi is under a bookcase or somewhere here in my office. I use it all the time for demos. It runs great. It's been running for a long time, and it does its job very well. And it's been running K3S from the very beginning. But as you dig on down, you see the traditional SUSE products, and these provide a great base to run your Kubernetes-based products on that are up above, or other applications that you may be able to do that you may need for your environment. We have the flagship product, which is SUSE Linux Enterprise. We also have variations of that product, which are things like SLES for SAP. We have the SLE Micro, which is a new version that's really aimed at running containerized workloads. and so we have that things like that. We also have the SLE desktop and point of sale system, and then the SLE extensions, the things like the high availability extension and the real time extensions. So we have other flavors of SLES that we can offer, and I would urge you to check out some of the other sessions at SUSECon that talk more about those. And then we have over on the side SUSE Manager, which is the fine product that allows you to manage all of the Linux systems running in your environment, no matter who you get them from, whether it's Red Hat, whether it's Ubuntu, uh, Rocky, or Alma, things like that. We can manage all of those various Linux distributions that are running in your environment, keeping them compliant, patched, and easy to make upgrades and those kind of things. SUSE Manager provides that kind of a framework. Then, if you look at the bottom of this page, you see the various places that you can run all of this stuff, whether it's in a dev environment, which is what we'll be talking about today, or if you're running in your own data centers on prem, if you're running in cloud, if you're running out at branch offices, or running at the edge. You may be running, in a freight car or a factory floor or a bottling plant or whatever it might be. We can operate at those places as well. And so we want to be able to run your solutions that you've developed anywhere that you need to run them at. And that's really what we're all about. So let's dig into this whole idea about running Kubernetes on the desktop. Well, why would you want to run Kubernetes on the desktop in the first place? Well, we find that most developers want to be able to run Kubernetes where they're working at. We find developers like to work from coffee shops. They like to work out on their back deck or on their front porch, wherever they're trying to tackle the latest problem that they're working on. Not always at the office and not always sitting at their desk. So they're working on these problems wherever they're at, and they like to be able to have that environment with them to be able to test things as they make changes and they make improvements to the code that they're working on. They can test it out right away in the same Kubernetes environment that you're using to deploy in. And so that's another important thing that we keep in mind. So the ability to run Kubernetes on a desktop has been something that the market has needed for quite a while. Well, really, the first one of these that came along was probably Minikube, and you probably are familiar with Minikube. It's the first Kubernetes system I ever used was Minikube, and it works very well. It's fine, but it's very terminal based, and it's very tied to Docker as well. So it kind of has a feel of a toy, and I guess it sort of is. There's a lot of folks actually use it to test things and check things out, but it is a viable situation for some folks, or a viable solution for some folks, I should say. Um, we then take a look at K3S, K3D, and that's the same K3S I mentioned before. That's our very lightweight Kubernetes distribution that's come out of Rancher. But K3D is this idea of running K3S on top of Docker. Again, as I mentioned there on the slide, you notice a Docker theme here. Being able to run this stuff on top of Docker seems to be de rigueur in this whole idea. Actually, running in the terminal is also a big thing going on here. That there's not a lot of really desktop-friendly kind of products that are out there. So the ones that we're taking a look at are in that theme. Now, one that breaks away from that is Docker Desktop. And a lot of folks have tried Docker Desktop out. But one thing I want to warn you about with Docker Desktop is not open source. And if you're using it at any scale within a company's development environment or something like that, the folks at Docker are going to send you a bill for using Docker Desktop. So it's free to download, but once you start using it, they're going to want you to pay for it. And that's fine if you want to pay for it, but that was what we were kind of facing. We didn't want to get that bill. We have a lot of folks developing a lot of code inside of SUSE that need this kind of an environment because we have software developers too, and they have the same needs that you probably have. Now, I love this slide and hate this slide, but what this actually shows here is the number of versions of Android that are in use at any given time. So if you go back to say, November of 2019, you can look there and you can see that, you've got a ton of uh, versions of Android that are running at any given time, and it changes over time. That, as the older versions age out and the newer ones become more robust, they become more prevalent. New ones are introduced, and they have a very small slice of the pie. If you looked at Kubernetes, it would be exactly the same way. We wouldn't be talking about the various flavors of Android, but we would be talking about the various flavors of Kubernetes that are in use at any given time. So what this is really representing here is this whole idea that you can't um, you can't really dictate to your developers that they use the exact same version of Kubernetes that you're using in production unless you can give them that tool that can do that. That's one of the things you're going to find out as we talk more about Rancher Desktop. We saw that as a need because you may have some container projects that you're working on that have to have a specific version of Kubernetes to deploy on. And so in those cases, you want to be able to run that exact same version on your desktop product so you could test against that particular version of Kubernetes. And then you may have different projects that are going along and they're more advanced and can run on a newer version. And you want to be able to test those projects and products on that version of Kubernetes. And so the ability to switch in and switch out the versions is really important and is one of the design considerations behind Rancher Desktop. So as we dug through this, we discovered there really weren't any great open source Kubernetes desktop apps out there. Really, the last one that had any kind of following at all was something called KubeSolo. KubeSolo was built for the Mac. And it was an open source project and it had really nice desktop characteristics, but it doesn't seem to be maintained anymore, and is not getting a lot of love from its community. And so that's why we decided to go off and pick up another product that we could build out of upstream, cloud native solutions. And so that's where Rancher Desktop really comes in. Is we've taken and assembled a product that is based on completely on open source. It's 100% free. Again, I work in sales. I can't sell you this product. I don't have a SKU. It is 100% open source, community supported. We have a very fantastic development team that's working on this product, and they have lots of experience in building out Kubernetes and digging in to make it work on various platforms. You could download it at rancherdesktop.io. Just go out there and grab a copy for your platform. It runs on Windows, it runs on Mac, it runs on Linux. We don't care which platform you run it on. I tend to run it mostly on Windows. That's what I have available to me. I have not tried it on a Mac because I just don't have a Mac that's capable of running it. But I have tried it on Linux and I've tried it on Windows, and it has a very similar feel on both platforms. And that's the idea behind it. We want you to be able to run it where your developers are actually what they're comfortable developing on. So if you take a look at the block diagram of what the product is, one of the really nice features about it is you can pick the runtime that you want to use. If your developers are more comfortable working in a Docker kind of framework, they can run it on top of Docker-D, and then they can use the Docker CLI commands. That's perfectly fine. A lot of people have the Docker commands sort of burned into their fingers, and that's what they want to type all the time, and that's perfectly fine. Just run a Rancher Desktop on top of Docker-D in that case. If you're a little more thinking more ahead and a little more advanced in things, and you're comfortable running in a container D environment, then you can use the nerd control commands. Nerdy control works great. It's very similar feel to what the Docker commands are. So we've got that available. We also use Helm and kubectl, so you can have those commands to use as well as you're interacting with the local Kubernetes that is running on your desktop. Now, if you've taken a look on Mac or Linux, we actually run this on top of a virtual machine running under QEMU, and that works perfectly fine. Now on Windows, it's a little different because we use the Windows subsystem for Linux, and you can pick whatever distribution you want to run it on. I tend to run it on OpenSUSE Leap, but it works fine on Ubuntu and other flavors of Linux as well. So you've got the choice that your developers have that choice. So, what were our design goals with Rancher Desktop? Well, basically, as I mentioned before, pick the version of Kubernetes you need to use. You get to choose. We're not going to hem you into one version of Kubernetes that we support in a given release of Rancher Desktop. We're going to support a whole bunch of releases of Kubernetes and make it easy for you to switch as you go along, because you may have different projects that you're working on at the same time that really need to have a different version of Kubernetes to test against, and that's exactly why we did it that way. And also pick that runtime that you want to use where you're more comfortable. If you're more comfortable with the Docker commands, use the Docker stuff. That's fine. If you want to use Containerd, we have that available to you as well. We wanted to leverage upstream projects, so we're using things like K3s and we're using things like Helm, and that's part of this whole project, that we're actually building it all out of open source. There's nothing hidden. There's no magic going on here. There's nothing proprietary. You can download the source code and take a look and contribute back to the community. We would love that too. That would be totally great. Um, uh, Also, another thing we wanted to be able to do is make it easy to install and easy to upgrade, because we know we're pushing out upgrades fairly regularly on this product. We want to make those upgrades be seamless as possible. I've been using this since 0. I think my first version was 0.4, and we're up to 1.81, I believe now. This upgrades have all been just very simple and very easy. I've not had one issue with trying to do an upgrade with this product. Also, easy installation. We built installers for Mac and for Linux and Windows. So it's very, if your users are used to those platforms, they're going to have a very comfortable installation procedure that they're going to be used to seeing. So it'll be very simple. We also want to be able to tie in container tool chains that you might be using if you have development environments that you've set up, different editors or tools, VSL, things like that. We want to be able to let you tie those things in, things like GitHub or GitLab, being able to pull things in and out of those environments, which is very, very common with developers these days. That's all part of what Rancher Desktop can bring to the table. And again, just want to give you some the other things that are going on here at SUSECon that you could dig into and take a look at. There's several sessions there: Prod 1227, Tutorial 1300, and Hands-on Lab 1606 are all about Rancher Desktop and actually using Rancher Desktop as part of those sessions. If you want to dig back into SUSECon 2022, there were a bunch of sessions in the archives there that also showed Rancher Desktop. There is also a great demo out there, and that's on YouTube. I'll give you the URL there. I won't try to say that out, but you can see that link right there. There's a great demo on Rancher Desktop out there available. And again, the source where you can go to pull Rancher Desktop down and try it out in your environment is there at rancherdesktop.io. Again, it's totally free, 100% free. It's all open source. I don't have a SKU. I can't sell it to you if I wanted to. It's totally free for your use. And the only thing we ask is you just contribute back to the community and become part of the folks that are out there and helping each other. And as they run into issues or questions, everybody help each other. That's the whole ethos behind the open source world. Well, now I'm going to turn it over to Colin to actually give you the demo. Thank you very much for your time, and we hope you enjoy the demo.
Hi, my name is Colin Griffin. I'm Chief Engineer at Crumware and also a practicing cloud-native software developer. Today, I'm here to show you Rancher Desktop and how it benefits workflows for software developers that are using Docker and Kubernetes, or should be using Docker and Kubernetes as a part of their local development workflows. What I'm going to do is I'm going to show you a quick tour of Rancher Desktop and some of the settings and setup for Rancher Desktop, and then work through several different Docker workflows. All right, let's get started. Let's switch over to our IDE. So just as a little bit of background for my environment, I develop in Docker. I don't install very many of the dependencies required for a local machine. I typically just install Docker and roll with that. Most of the dependencies on my machine get installed into the container directly and run from the container directly. Leveraging Rancher Desktop allows me to do that so that I can develop in a Kubernetes native workflow. I'll quickly show you Rancher Desktop, and for the sake of time, we're not going to go through the install process, but initial install and first boot takes about 1 to 2 minutes. All right, what we see on the screen here is the Rancher UI, the Rancher Desktop UI. We have some general quality of life tools in place that help us debug our environments as well as manage our Docker environments. Right off the bat, we have a nice in-your-face version control. Today, we're using 1.9 tech preview. We're looking forward to 1.9 being a full release soon because it contains some really nice features around Docker extensions. So we have a general information screen here. We also have a port forwarding screen, which we can use to more conveniently create port forwards. Typically, that's something in Kubernetes we have to do in the command line. We can also see a list of images that we've already been running on our machines. We have several different troubleshooting tools that we can use, as well as have easy access to our log folder and our log files. We have diagnostics. And then also new to 1.9, as mentioned, is the integration with Docker plugins. All right, just some background on my environment. I am running this on Windows and in WSL. I typically do my software development in WSL as well. Looking at preferences, when we do our initial setup, we have some really nice behavioral things. So we can actually choose for Rancher Desktop to start on boot. We can choose for it to start in the background and stay up and remaining as well. Personally, I prefer to have the Docker daemon stop when I close Rancher Desktop, but we're able to make choices here. Right off the bat, with WSL integration, we need to choose which distribution we want to integrate with. That gives us seamless access to the Docker command line tools from our WSL instance, as well as from PowerShell on Windows. That allows them to both use Rancher Desktop at the same time. The container engine here is really important. Typically, the default is Containerd and nerdctl, but we're actually switching over and choosing to use Dockerd and Moby because that's what the majority of the guides that are available online are still using, especially as folks get familiar with starting Docker workflows and bringing this into their tool set. On the other side of that as well, we can choose whether or not we want to run Kubernetes, but we can also choose a myriad of different versions. So we're running 1.2.6.5 as the latest stable version of Kubernetes, and this stays very, very, very up to date, maybe too up to date, but it does allow us to switch back to previous versions if we need to. And that takes probably about a minute to switch versions. Underneath the hood, we're running K3s, which makes that really, really easy. Also, a quick note here, traffic is included. This is really nice for software developers. Typically, one of the first things that we introduce into a flow for a software developer is the introduction of so that they can treat their local environment like production. And we'll touch on that in a little bit when we show some of the workflows. That's the complete tour. It's really simple to add extensions as well, just to show that right out of the gate. Logs Explorer is a great extension to browse the logs for running containers in the background. All I have to do is select it, click install. This takes maybe about 10 seconds, and boom, I have a Docker plugin in place that allows me to easily browse my logs. And a motorcycle just went by. I'm going to go ahead and switch over to my IDE and show you some workflows and get through as much as we can with time. So the first workflow that I'm going to show is the really typical one. I want to check to make sure that Docker is available. So I have access to Docker. You can see I have a lot of different containers running here. Kubernetes actually runs within containers in this environment. So we can check out and browse those and tail those logs for the different containers if we need to. The first thing that I'm going to do is the first step that any developer typically takes. I'm going to run the hello world, the typical Docker hello world, and just prove that this is working as expected. Live coding, I forget my dash IT. Let's see if we can do this in one take. All right, I'll just pull this up here. And let's enlarge our environment as well so that everybody can read. All right, so we actually see here, if it lets me, there we go. So here's our hello world running in the wild, and my computer doesn't like that. We have our hello from Docker, so Docker's up and running. So we just did a typical Docker run. A lot of people are going to start there. Next, I'm going to switch over to Docker Compose. Docker Compose is probably the first tool that people will use to run multi-container workflows. We've actually cloned a repository from a project called cal.com. It's a great replacement for Calendly or a self-hosted alternative for a scheduling tool. It's really easy to pull this. Go check out the project and pull that down and get it running on your local instances. So here I've got the repository cloned. If we actually take a look, we can see in our file browser here that we have a pretty typical structure. We've got Docker files. We also have source files, scripts, and we have a Docker Compose file. In that Docker Compose file, we have full Docker Compose functionality with volumes, networks, everything running the gamut. So we're hosting Postgres with a front end and a back end and tying that all together. So all I need to do is do Docker Compose up. Let's select Calcom as the service so we don't run everything. And get that started. So I have already pulled these images. It will pull the images, and this is all native Docker Compose. So here we're applying our migrations. So we're getting a fully populated database because they did a great job as a tool at Calcom, including that as a part of the onboarding process. So this is about to spin up, and in 10, 15 seconds, we have a fully running self-hosted instance of the Calcom UI. Also, we're going ahead and putting this into, zoom in on the browser too and prepare that. This is going to localhost 3000, so same convenience that most users are used to. All right, let's move on. Next thing that we're going to show, once people typically graduate from Docker Compose, they move on to Helm. So since we're doing this in a Kubernetes environment, we actually can, as developers, go ahead and deploy applications into Helm as if they were on a standard cluster, because we are a cluster at this point. A tool that I'm going to deploy is called KubeCost. KubeCost is a great tool that allows us to estimate and monitor costs for our cluster environment and get breakdowns all the way down to the workload level. This is really important for developers to understand how much their individual pods and containers are costing the overall environment instead of our typical node pricing model that we learn as software developers. So this gives us much more granular information and helps us collaborate with UIT ops folks and make sure we're not costing the organization too much money. All right, so let me switch back to that here. So we're going to use a Helm upgrade install command. But first, we're going to go ahead and check and add the repository. So here, I'm just showing I'm using native command line tools. We already have KubeCost added as a Helm repository. And then I'm going to go ahead and run Helm upgrade KubeCost. So here we go. We're running it. And that's going to replace and upgrade depending on if I've changed any variables in my configuration. So it looks like we're up and running. Let me do kubectl. And check to make sure that the pods are good. So kubectl get pods, namespace, KubeCost. All right, good to go. So now I'm learning how to use kubectl. All right, and then the next step, which is pretty typical for initial Helm installs where we haven't provided an ingress object, I'm going to use kubectl port forward. Let's get back to my IDE here. So we're creating a Kubernetes port forward. That's going to port 9090. So let's take a look at that locally. And there we go. We have a full KubeCost implementation. And now I can actually monitor my local workloads and don't need a remote KubeCost instance to get started with testing that and learning from it as a developer. All right, back to the IDE. So we mentioned traffic earlier. So traffic will actually integrate and use the native ingress objects as well as detect the service names that we've created in our Docker Compose as well. It's really, really flexible. And that makes it so that we don't have to necessarily hit localhost port number in our local environment. Rancher Desktop will go ahead and, even on Windows, redirect port 80 and 443 via the load balancer into our services so that we don't have to go into port hell and try to rename all of our different services to be on different ports. So I'm actually going to deploy our website. So our website uses a tool called Scaffold in combination with Helm. What Scaffold lets us do is it lets us add some additional configuration items, some developer quality of life that will manage the container lifecycle for us from build out to deploy, out to run and Helm install. And we can even do that to remote clusters. Also, the additional thing that's really nice for developers is we'll do volume mounting. It will actually take files from my local machine and smart hot swap them with remote workloads. In this case, it's a local workload, but we're treating it as remote. And that definitely makes us do a Kubernetes native development flow, but also not have to rebuild our images every single time we want to make a change to our source code. So how I do that is I run scaffold dev. Scaffold is going to take some configuration from my scaffold.yaml, which also contains some values that would have typically passed in with my Helm values file. So you can see that it's actually checking for existence of the image. I've already built it. It goes ahead and I don't need to push it to my local. So you can see that it hashes it with a unique hash or a dirty hash and then runs that environment locally. That helps with conflicts when we've already got latest pulled and if we use latest, then sometimes we won't pull our latest images. It will just run the latest instance of latest that we have. So this ensures that we get the latest and greatest from our local machine. So this is deployed in Ingress and is running on crumweb.localhost. You notice that there's no port value here. So I'm going to go ahead and open that in the local browser. And here we have our website running. So I can change files here, source code, hot swap images. It's great. It's good to go. Now, if I switch back, a nice, easy, convenient thing. I want to deploy this to a remote cluster so that another developer can check this out, or so I can try it with a customer, or I can just make sure that this runs in production properly. So I'm going to use scaffold dev, and I'm going to add a profile that's already available that I've called live, which points at a remote Rancher instance and actually deploys these workloads to that instance. As a developer, what I've done is I've logged into Rancher, I've downloaded a kubeconfig from Rancher, applied it on my local machine, and then referenced to that Kubernetes context by name, and live has that by name. So this is going to check for a local build of an image. It's going to push it up to a remote registry, and it will run that workflow. Now, this might take just a second because I don't know how the bandwidth is at this location where I'm recording, but we'll give it a go. All right, so we see that it's tagged again. We've got dirty tags. It's starting to deploy. So we've actually done that. Now I also specified in my configuration, I've added an ingress object, which is going to be used by the remote machine. On the remote cluster, I have external DNS and Let's Encrypt via Cert Manager already running and ready to go to generate my certificates. So we'll see here that I've got it generated URLs for me with an HTTPS, which is colin.web.crum.io. It probably won't be active, but you can try to hit it as you go access our website to make sure you contact us. So here it looks like our rollout has completed. So let's take a look. Let me get the URL here. Let's launch that. All right. So now we're accessing our remote cluster with our workloads. They may still be spinning up. This is where the live coding peril comes in. There we go. Now it's launching. All right. So that is actually a remote/local instance that's running that was pushed by my local machine. And we don't have time to show, but if I just quickly change a source file, it will hot swap. And I can see my changes live in a production environment. We talk about remote container development when we don't have really strong resources on our local machine. This is a great example of that, being able to push this and run this remotely and take advantage of the additional resources available in the remote cluster for me. All right, so I'm going to Control-C, stop the process. That's going to clean everything up. One thing we also didn't show is those logs would automatically be tailed and show on my local machine in case something happened behind the scenes and I needed access to those logs. So in summary, we've run through and looked at some of the nice quality of life features and settings in Rancher Desktop. And we've proven and shown that we can run very simple Docker workflows all the way up through complex developer workflows that really aren't that complex anymore. So this has been my tour of Rancher Desktop and developer workflows. Again, my name is Colin Griffin, Chief Engineer at Chromeware. I hope you guys have a great day. Thanks so much.